Okay, so I just read about ZOZO's contact solver, and I'm blown away by how it resolves physics-based simulations.
Right? The idea that it can handle interactions with shells, solids, and rods without penetration is pretty impressive.
Wait, seriously, so it eliminates all those annoying intersection issues? That's a game changer.
Absolutely. Plus, it's scalable to over 150 million contacts. Most simulations can't even handle a million.
That makes me wonder, though, how does it maintain performance with such a high contact count?
Good question. They run everything on the GPU in single precision, which optimizes performance significantly.
Ah, I see, but doesn't that limit the accuracy? Single precision can't be as precise as double precision, right?
True, but in this case, they prioritize speed and efficiency over maximum precision, which is often acceptable in simulations.
That's interesting, but I wonder if users might run into issues with less accuracy in critical simulations.
It definitely raises valid concerns, but they do have measures for bounded inextensibility. Cloth never extends beyond 1%.
Oh wow, that's a smart approach. It gives you that safety net without sacrificing too much performance.
Exactly. And they emphasize better physical accuracy through their finite element method too.
So it's not just about speed, they still care about realism. I appreciate that balance.
Definitely. And the fact that they run stress tests using GitHub Actions adds a layer of reliability.
Wait, they run tests 10 times in a row? That's rigorous.
Yeah, and it ensures that even a single failure flags the entire run as a failure, which is pretty strict.
I love that it shows they're serious about quality control, but does that slow down development?
It could, but I think they'd rather invest that time up front than deal with bugs later in production.
Fair point. Speaking of production, how accessible is this for average developers?
They designed it for cloud deployment, which allows users to access powerful simulations without needing expensive hardware.
Cool, so you can run it on platforms like Oz or even rent instances from services like Vast AI.
Exactly. It opens up a lot of opportunities for developers who don't have high-end GPUs.
But let's be real, what about the learning curve? Is the API user-friendly?
Actually, it's quite intuitive. They use method chaining similar to JavaScript, which makes it easier to work with.
Nice, and the documentation is well structured, right? It's essential for new users.
Yes, they've included docstring documentation, along with interactive linting assistance.
That's super helpful. It seems they thought about the user experience quite a bit.
For sure, though we should consider if the reliance on Docker limits some users who aren't familiar with it.
Good point, Docker can be tricky for those who have never used it, but maybe it's a necessary evil.
Possibly, it does streamline deployment and ensures a consistent environment.
So what's your take on their cloud focus? Is it the right direction?
I think so. It allows for cost-effective development and flexible scalability, which is a huge advantage.
And it makes advanced simulations more accessible to a broader audience. That's definitely a win.
Absolutely. But how sustainable is this model if users don't delete instances after using them?
Yikes, that's a real concern. They should probably stress that in their documentation.
Definitely. Users need reminders to avoid unnecessary costs.
So if we tie all this together, ZOZO's contact solver is innovative but comes with caveats.
Exactly. It's a robust tool with excellent features, but requires careful consideration from users.
It's a fascinating mix of performance and accessibility, but I wonder how long that will last.
Right? Technology evolves quickly, so they'll need to keep pushing boundaries to stay relevant.
Wait, imagine if they integrated real-time capabilities. That would be a major leap.
That would be wild, but it would also come with a whole new set of challenges.
Totally, but I'm excited to see where they go from here. This could change the game.
Same here. It feels like we're on the brink of something really exciting in simulation tech.
Absolutely, so for anyone listening, keep an eye on ZOZO's work. It's definitely worth watching.
And don't forget to check out their GitHub for all the latest updates and documentation.
Exactly, until next time, let's keep exploring the fascinating world of tech.